All right. Well, continuing on, we've in our series of learning about exoplanets and exoplanet detection, we've talked about pulsar timing, radial detection method as the star moves back and forth away from us and toward us, transit detection, where the planet moves in front of the star, and astrometry, where the star moves back and forth. Today, we're going to talk about spectroscopy, or more specifically, transmission spectroscopy. Now, this is not usually so much a detection of a planet. This would be a follow-on once a planet has been detected. But this is a very powerful tool in helping us understand the nature of that planet and the nature of the planet's atmosphere. So on the top up here, we have a little graphic showing that we have the star, and we pass that starlight through some instrument, a grating or a prism, or perhaps you use it for metric techniques, and you get a spectrum of the star. And here we see that over on the right. Then the planet moves in front of the star, and the star is still emitting, but some of that light is now going through the planet's atmosphere, tangentially through the atmosphere. And so that light gets broken up, and we see a series of absorption lines from the cooler planetary atmosphere. The planet's atmosphere is cooler than the star, so we see these lines from the various molecules or atoms in the star, in the planet's atmosphere in absorption. So we now have these two spectra. We have a spectrum of the star by itself, and we have a spectrum of the star plus the planet's atmosphere. And so now what you can do is you take the spectrum of the star plus the planet, you subtract the spectrum of the star, and you're left with the spectrum of the planet. And at that point, you can start to do modeling and assessment of what gases are present in the atmosphere at what altitudes. In other words, the different depths of these absorption lines are a product of the amount of that material in the atmosphere, as well as the temperature of the part of the atmosphere that those lines are coming from. So you can start to do a little physics to start to understand the planet a little bit better, and you can identify these lines. Here's a planetary atmosphere. These are molecules, and molecules have very strong absorption properties in the infrared. So we use a telescope like Spitzer, also an infrared telescope, just like James Webb, or similar to James Webb. And here we see acetylene and hydrogen cyanide and carbon dioxide, fairly common molecules. We know acetylene is in all of the outer planets plus Titan. Hydrogen cyanide, a building block of life, is in the atmosphere of Titan, and of course CO2 in the atmospheres of Mars, Venus, and Earth. So we look for biomarkers, we look for evidence of habitability, and of course, we look for water. And you all are real familiar with this by now. This is the James Webb Telescope spectrometer looking at an exoplanet. This was one of the first 5 pieces of data returned to the public a few weeks ago. And this image shows water lines in the atmosphere of the exoplanet that James Webb looked at. So this is a very powerful technique to help us, once the exoplanet has been found, to help us understand and characterize it, and maybe see if it is habitable, perhaps a place for life, and perhaps even showing biomarkers, possible signs of life. So I will just direct you once again to the NASA Exoplanet Archive. This is the image that I showed a week or 2 ago of the homepage for the NASA Exoplanet Archive. And you'll notice up here in the upper left, there were 5,054 confirmed planets. I pulled that image down today, and there are 5,069 confirmed planets. So the numbers are increasing almost every day. We have powerful telescopes in space that are looking for these, as well as ground-based telescopes. So this is a wonderful resource for you if you want to learn more about exoplanets. And once again, I will mention the Eyes On app. You can download to your phone. You can use it on your laptop that NASA JPL, Jet Propulsion Labs, has developed, which gives you the ability to zoom through the universe, find exoplanets, rotate their orbits, and rotate the planets themselves in 3D on your screen, and find out all about them. So that's it for exoplanets for today.
That looks so cool. I didn't even realize that you could open up the orbits and play. Oh, wow. Okay.
The Eyes On series is amazing. Eyes On exoplanets. You can also find Eyes On the solar system and Eyes On the Earth. Just amazing 3D graphics, fun to play with.
You know, it's really cool how they get those photographs. No, I'm kidding.
Hey, Kareem, lovely to talk to you.
It's coming. James Webb will help us with that.
Yeah.
Knock on wood.
No, unfortunately not. Okay, thank you very much for that, Lou. Very interesting.